right, so let's get started with tonight's topic, okay? So tonight's topic is rising and setting phenomenon, okay? Oh God, what the hell is that? So this is like the time of sunrise, sunset, moonrise, moonset. By the way, this is also the method you'll use to compute the twilights. Now, the instructions for this, okay, are in the Nautical Almanac. They're on page XXXII. It's towards the back of the book. It's in the appendices. XXXII. I think they're yellow. All right. And I'm not going to read these instructions. I'm not going to read these instructions with you. Okay. But if you look, these are the instructions. Okay. For everything, sunrise and moonrise. And then down here, this right here, this table 2, this is for the moon only. This is for the moon only. So we're going to be concentrating mostly on the sun. We're going to use the upper table. If you were to do the moon, though, you do the upper table, and then you'd have to use the lower table as well. And the instructions for the lower table are given down there as well. Okay, but what I'm going to do now is I'm just going to throw the instructions together in the PowerPoint here. All right, so here's a question for you. Zoomers, you can see the PowerPoint, right?
Yeah.
Okay.
Yes.
Yeah. Okay. Okay. So 13 February 1981 at 0325 zone time. All right. Your DR position is whatever that frickin' is right there. Okay. All right. Okay. Your DR position is 2320 by 155.15. You're steering 240 at a speed of 13.6 knots. What is the time of sunrise? Okay. What is the time of sunrise? So first thing I think you want to pick up on the fact is that it's 3:30 in the morning. Okay. And you're at 23 north. So the freaking sun ain't coming up for a few hours. Okay. Now, if you're up in the freaking pole, okay, the sun might come up early, might be up already, depending on what time of year it is, but the sun ain't coming up for a few hours, which means you're going to need to do some kind of advancing, okay? So what you got to do here is, now I'm going to list the instructions. You can write them down if you want or not, okay? You may understand them or not at this point, but these are the instructions we're going to follow, all right? These are the instructions we're going to follow. So you're going to interpolate your latitude, okay, using the Nautical Almanac. Step 1 is you're going to have to interpolate for the time of sunrise for your latitude and a central meridian, okay? 1. Interpolate for latitude. Okay? This is what's called the first estimate, all right? And what we're going to do is we're going to cozy up. We're going to cozy up to what we think the time of sunrise is going to be in 2 steps. First, we're going to cozy up to it, approximating the time for our latitude. And then we're going to cozy up to it with a second step that accounts for our longitude. So really, in fact, it's actually first account for your latitude, second account for your longitude. This is north, and okay? 2 steps. Well, I got the clicker here. I don't understand exactly. So now, how are you going to do that? There's a freaking table that you can use in the back of the book. I'm going to show you how to do that tonight. But I think you should just do it by shortcut. Okay, you can approximate it. If you do this method, you'll never be more than 1 minute off of the Coast Guard. This is the method I use in the real life. Okay, just by eyeballing. Okay, who cares if you're 1 or 2 minutes off, really? Unless, of course, you work on a cruise ship. And then the passengers might be pissed if they came up 2 minutes late because you told them, yeah, okay. I had that happen. I used to be on a passenger ship. Yeah, you had to get the freaking sunrise nailed down. Otherwise, you heard from the cruise director. Julie was her name. Okay, step 2. Advance to time step one. Okay? So we're going to figure out what time it's going to happen for our latitude. Then we're going to advance to that time. Okay? Now we're getting ready for our second. Okay? We're getting ready for our second cozying up. All right? Now, how are you going to do the advance? You can do the plotting sheet. You can DR from the initial fix given in the problem on the plotting sheet. There's a little shortcut I'll show you at the end where you can just use any frickin' spot on the plotting sheet. Okay? You can use a sailing. I'm not going to teach you how to do that until the next test, but you can use plain sailing for this. You can do the down and dirty. I'm going to show you the down and dirty again tonight. Same down and dirty we used last time. Okay? Okay. So, you're going to advance using one of those methods. Then, what you're going to do for step 3 is you're going to convert your longitude from arc to time and apply it to time from step 1. Okay? First estimate for your latitude. Advance to the time from step 1. Take the longitude from the advance, convert it from arc to time, and apply it to the time from step 1. You're done. Okay? And I'll show you how you can apply it to your central meridian. Ooh, you son of a shit. With the hands. With the hands. That's your job. Okay? Okay, move. Okay? All right. So, and I'll show you 2 different ways of doing that. One of them you've probably already used, which is using your own central meridian. I recommend you use Greenwich meridian. Okay. So, we're going to do a problem.
You go back to that slide for 1 second.
Yeah. Oh, by the way, this PowerPoint is already up on Canvas. Okay. So, I mean, that is a ton of, that's a shit ton of words right there. Okay. You're not going to use all of them because you're going to fall into some method. Okay. But this right here, these are the this is the shorthand for the instructions. Okay. And we're just going to rattle through these instructions. Okay.
All right, good.
Cool. Okay, we're doing problem 1 on your freaking worksheet. Okay, so it's 13 February 1981, 0325. Okay, all right. So a little bit of data I'm going to collect for this problem. Dates. Okay, in this case it's 13 Feb. The body. Am I talking about the sun, the moon, what? Okay, and I'm just going to say sunrise. So I know it's the sun and it's rising. Latitude is pretty standard, 2320 north. My longitude, that's where I'm starting. It's at 155.15 west. My zone time is 0325. And my course is 240. And my speed is 13.6. Okay? 13.6. So I collected some of that data there. Okay? All right, now we're going to do step 1. We're going to do step 1, interpolate for latitude. My latitude is 23. My latitude is 2320. Okay? So now we got to go into the book and do our first estimate. And we're going to find out what time is sunrise on every central meridian at 2320. So we go to the good book. And here's the good book. Okay, so we go to April 13. Okay? Excuse me, February 13. Okay, April Fool. Okay, anyway. All right, and we're going to find the sunrise column. All right? So we got our sunrise column. And now what we're going to do is we're going to look in this latitude over here. And we're going to say, okay, we're north, and here's a north 20, and here's a north 30. Okay, there's no north 2320. So what I'm going to do is I'm going to find the 30 and the 20. You should be on page 39. Okay, all right, on the right-hand page, sunrise 30 and 20, and you'll see that for 30, sunrise is at 0642, and for 20, it rises at 0630. Okay, now, just as a little reminder, these times are valid for every central meridian. So that's 0, 15, 30, 45, west or east, okay? All right, so if you look at that, at 20 degrees north, it was 0630. At 30 degrees north, it was 0642, okay? So 06, what do we got here? We got 30, 20, 0642, 0630. That's 12 minutes. The difference from here to there was 12 minutes. Okay? 12 minutes. Well, you know what? What's my latitude? 2320. Okay, my latitude is 2320. So I'm kind of between these two. But 3 is about a third of the way. 23 is about a third of the way to 30, right? So my correction should be about a third of 12. So my correction should be how many minutes? 4. So my first estimate is 0630 plus 4 minutes. It's 0634. Okay? I just did this estimate by eye. Later on, I'll show those who want, some of you may be, I don't want to do it by eye. I want to do it using a table. I'll show you how to use a table at the end. Okay? But this is, you might be off by a minute doing this, but that won't matter. Okay? So my first estimate is 0634. Step 1, done. Okay, questions about that? That was just a little eyeball interpolation. It works great. Okay, now we're going to go to step 2. We're going to advance to this time. So to advance to this time, I bust out my plotting sheet. I'm going to do my little lines here. That's 0 degree longitude. That's the equator. I'm 2320, 155. I'm in this quadrant. Okay, so I'm in the northern hemisphere, the western hemisphere. So I'm just going to put a dot there. And I just want to get an idea. Am I going west? Am I going north? Whatever. I'm going 240. So that's west and a little bit south. Okay, so I'm doing that. Okay, I got a mental image in my head. Hey, as I go, I'm getting more and more west longitude. Okay, and I'm going to get a little bit further south, but not much because I'm mostly going west. Okay, so what I need to do now is I need to advance from 0325. So now, all right, that was step 1. Step 2. Advance 0325 to 0634. Okay? 0634 was the time from 1. Now I'm going to advance to the time from 1. Okay? So on your plotting sheet, you just bust it out. You plot your 0325 position, and then you run your DR out. Okay? So I'm going to show you a little picture of that now. Okay? Before I do that, I just want to explain a little something to you, okay? In case you didn't figure it out, okay? These times are on any central meridian. So this is supposed to be like any central meridian. And so For 20, it's 0630. For 30, it's 0642. So what's the freaking time for 2320? It's a third. It's 23, it's a third of that time, so it's 0634. There's like a little picture of what we just did, okay? Any questions about that? Okay, now we need to advance to that. So now that's the next step. So we did the first estimate. We got 0634. Now we're going to do our advance. So this is, I actually plotted the 0325 position on a piece of plotting sheet, okay? And then I advanced, I used my time going 240, 13.6 knots. My advance should have been, I don't know what it was. My advance was 0634. That is 3 hours and 9 minutes, okay, times 13.6 knots. And that gave me 42.8 nautical miles. So I got to advance 42.8 nautical miles. And that's what I did right here. I put 0325 position, that's 240, and I measured 42.8 miles, and bada bing, bada bang, I got that spot, 0634. Step 2, done. Okay? Step 2 is done. Now, I'm at step 3. Step 3. It says convert your longitude, okay? Oh, by the way, so, well, let me get over here because you can't, yeah, okay. So here we go. That is my DR position. Now I need to extract that longitude. And I didn't, it turns out that on the plotting sheet, that was 155.55, okay? So longitude at 0634 was 155.55 west. Okay? I'm going to take any questions at this point before I go to the next step. If you don't want to do this plotting, you can do the down and dirty. I'll come back and look the down and dirty again in a few minutes. I'm not throwing the down and dirty in yet until the end. Okay? That's the textbook way to advance. You're advancing because you need this longitude. This longitude is the longitude at about 0634, your first estimate. Now we got to take this and we got to do step 3, arc to time. So, convert arc to time. All right. So, we're back to this picture. Okay, 0630, 0642. For 2320, we were 0634. That's our first estimate. Then we did our advance. Okay? Now, what I'm going to do for this, how many of you were taught, okay, oh, well, if it's 155, I got to find my central meridian. It's 150. Oh, so now it's 150. So I'm 5 minutes and 55 minutes to the west of it. But of course, if I was, so I add the time. But of course, if I was east to it, I got to subtract the time. How many of you did that? That is a serious pain in the ass. Plus, you got to consider what time zone you're in. I'm going to show you a way to do it right now that is wicked ass simple. Okay? So if you just trust me for a minute and go with it, I think you might like this way better. If you don't like it, I'll show you the way you learned in the second step. So what I'm going to do here is I'm not going to do it from 150. I'm going to pretend that I was at Greenwich. Okay? This 0634 is any central meridian. It's any central meridian, including Greenwich meridian. So what I'm going to do is I'm going to take that and I'm going to say it's 0634 in GMT. Okay? That's my first estimate. It's 2320 by 000 west. And now what I'm going to do is I'm going to apply all 155 degrees and 55 minutes as time. So I got to do arc to time for the complete longitude 155 and the 55 minutes, okay? So how am I going to do that? I don't think I have a picture of this, okay? So what you're going to need to do is go to the arc time page, which I think is the first yellow page, and look up 155. What do you get for arc time for 155? Where is the frickin' page? Okay. So what I'm going to do here is I'm going to do the entire thing all the way to 155. Here is 155. It's 10 hours, 20 minutes of arc. Okay? Everybody see that? It's paid, it's right after Polaris, so it should be 277, or it's right after 276. You gotta keep getting. I think it's the first yellow page. Okay? First yellow page. Okay, so 155 is 10 hours, 20 minutes. Okay? So what I'm going to do here is I'm going to write 155 degrees, and I'm going to go 10, 20. Okay? So what that means is it's going to take 10 hours and 20 minutes for the sun to go from Greenwich to 155. Now I got to do my 55 minutes. Okay? So for the 55 minutes, I come over to this side, and I slide down to 55. And it's 3 minutes and 40 seconds. 3 minutes and 40 seconds. I don't give a rat's ass about the 40 seconds. I'm going to say it's 4 minutes. Okay? 4 minutes is close enough. I don't give a shit about the 20 seconds. I'm going to round up or round down using the regular rules of rounding. Okay? So, 4 minutes. So what that means is, for the sun to go from Greenwich Meridian to 155 and 55 is going to take 10 hours and 24 minutes. So now I just add it all. Okay? So what do I get? I get 8, 5, right? 4, 5, 6, 1658. Okay? Okay? You okay with that? What time zone is that? GMT. What's my zone description? What's my zone description? If you look on page 370 of the Bowditch.
Plus 10.
Okay, what is it?
Plus 10.
Okay, plus 10. Okay, so my zone description is plus 10, but the plus 10 is plus when I'm going to GMT. I'm going to go from GMT to my zone. So what am I going to do with the plus 10? I'm going to subtract it. And I get 0.658. And that's the answer. If you look at the key, it's 0.657, your 1 minute difference. Okay? But if you look at all the times on the answer key, okay, so here's the answer key. 0.652, 0.657, you're only 1 minute off, which is what I told you at the beginning. Okay? So, and that's plenty good. All right? I think this is easier than doing it from the central meridian. Okay? But if you want to do it from your central meridian, I'm going to do it again from the central meridian. Okay? So, from the central meridian, looking at the PowerPoint, your central meridian is 150, which means you're 5 degrees, 55 minutes west of that. Now, this isn't too hard. The pain in the ass is when you're east of it, you got to subtract it. Okay? So, I call this method that we just did the wicked easy always add, because you never have to subtract, you always add. That's why it's wicked easy, you always add. Okay? But in this case, it's not too bad. But if you were to do it, your first estimate was 0634. Okay, then you're 5 degrees, 55. So you go back to the book and, you know, you use 5 degrees, it's 4 degrees, it should be 20. Yeah, there it is, it's 20. Okay, because it's 4 degrees for every, 4 minutes for every 1 degree. So funny. Okay, so that would be 0634 local time, 20 and 4, which is 0658. Done. Okay, now I will tell you though, using this other method here, in the real world, you're going to get all screwed up using this second method if you're not keeping your time zone on the ship. And that's often common because now you got to start thinking, well, what time zone am I in? You never have to worry about that if you treat it as Greenwich and just apply the zone description of what you're actually keeping. Works every time. Okay? Questions about that? Yeah, you got a whole freaking worksheet of them.
I have a super quick question.
What's the question on Zoom?
So to do that super quick, easy way, we only need the corrected longitude and then our corrected the 0634, correct?
Yeah, so the first thing you got to do is figure out the first estimate, which is the latitude that you're at and any central meridian.
Okay.
Okay? And then you got to advance to that time. And then you get that longitude. So when you're saying corrected, I think so explain back to me the steps as you understand them. What's the first step?
To take your the 0630 time from 20 and you're gonna add 4 degrees because that's your difference.
It's 4 minutes.
Yeah, 4 minutes. That's what I meant. Sorry.
Yep.
So then you get 0634.
Yep.
And then this is kind of where I got a little lost. So I did distance equals speed times time. And then I got 42 nautical miles. And then what do I do with that 42 nautical mile?
So you got to advance that from your 03. Okay?
Okay.
So this is your 0325 position. That's 2320 by 155.15.
Yep.
And then this line that you see here, that's the 42 miles that you needed to advance on course 23240 to get to your 0634 DR position.
Okay.
Okay? That's not me blowing up your phone.
Yeah, no, sorry.
It's one of the bastards inside the freaking class here. Okay? All right.
Okay. Yeah, I think I understand it.
Then you take this longitude for 0634, and that's the thing you do the arc time to. What was your question? Did you have a question?
Yeah, you said you always add, but what if it was like?
You're not gonna get any problems like that on the Coast Guard, but it still works.
Still works?
Yes.
You just add?
Yeah, but I don't want to dive into it right now. Okay? The method is still gonna work. Okay? All right. So I haven't seen any problems on the Coast Guard that were east. Okay, but there's also like a GHA method you could use, but we're not going to worry about that. Okay. All right. So now we're just going to button up a couple of things. Okay. I'm going to show you if you don't want. So in that first step, we eyeballed it. Okay. So if you don't want to eyeball, you want to do it the long way. There's a table. I'm going to walk you through using that table now. Okay. These are the instructions on that page XXXII. Okay. And, you got to get the just look at all these instructions. These are the freaking instructions. That's step 1. Get the tabular interval. Get the difference between the tabular times. Okay. It's much easier to eyeball interpolate it, but this is what you're going to do. There's this table in the back of the book. Okay. And it says, if you read those instructions down there at the bottom, table 1 is for interpolating the local mean time to sunrise, blah, 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 is to be entered in the appropriate column on the left with the difference between true latitude and the nearest tabular latitude. Okay, so here's how you enter it. Remember there was 20 and 30, right? Our time was 23:20. That's 10. From here to there is 10. Okay? So between 30 and 20, the difference is 10. So what I'm going to do now is, okay, it's 10 degrees. So on this table, which is on page XXXIII, I got to choose this column here for 10 degrees. Okay? Then it says, now you got to take the, then you take the difference between the lower latitude, 20, and 23:20. So that difference is 3 degrees, 20 minutes. You get the difference between those two, 3 degrees, 20 minutes. And then you slide down this column until you find the closest thing to 3 degrees, 20 minutes. That's 3 degrees, 30 minutes. Okay, so the lower latitude is 20, 23:20, 3 degrees, 20 minutes, that's the difference. So there you go, 3:30 is as close as we can get. Okay, then it says you got to take the time difference between the time of the lower and the time of the upper. So that was 30, that was 12 minutes. And then you got to find the freaking column over here that's closest to that. So 12 is between 10 and 15. And then you come down here and here's your correction, which is between 3 and 5, it's 4 minutes. So 0630 plus 4 is 0634. Boom. Okay? So you can do all that stuff, or you can interpolate by eye. Okay? So if there's anybody wants to, I kind of went over that quickly. If you have trouble interpolating by eye, you're going to want to use this table, and I'll come back and work with anybody that wants to do that later on. Okay? We could have interpolated by eye, and we would have gotten the exact same number. Complete solution for this example. Okay, this is all done up on the board already. Okay. Just as a shortcut here, anyway, this is all, we've already done all of this. It's just sort of putting it all together. All right. You do your first estimate, you do your advance, you do your arc to time, okay, and you get your answer. All right, first estimate, step 1, advance to the time from step 1, get the longitude, advance to that longitude, get your answer. Okay, arc to time. And you can do it by Greenwich Meridian or Central Meridian, whichever you prefer. Okay, and this here I was doing it from your Central Meridian, and this was I was doing it from the Greenwich Meridian. And this is all up on the board. Okay, but it's also in the PowerPoint. Common mistakes. Here's a common mistake. Okay, here's a common mistake. See this right here? This is north latitude. But you're in south latitude, but you use the north latitude rows. That's a common mistake. Here's another common mistake. This up here is for sunrise. Sunset is down here. So you're doing sunset, but you use the table for sunrise. That's another common mistake. For some reason or other, probably because we live in the northern hemisphere and we like sunrise more than sunset because sun's coming up, glorious day ahead of us, sun going down. Oh crap, predators come out, okay? Or we got to do ANAV, okay? So people seem to gravitate to the north and sunrise section of this book. You might be in the south and the sunset section. Using the wrong column on sunset. Okay, applying arc to time incorrectly, usually in east longitude. Okay, or if you're east, usually if you're east of your central meridian. Okay, all right. So Ren, this by the way is a little bit of a bigger picture of the plotting sheet that I used. Okay, this is a little bit of a bigger picture of the plotting sheet that I used. This was my 0325 DR position, my 0325 fix. Okay, and I did this plot. That was the 42 miles on 240, and I got 155.55. but I could have done the down and dirty. If I was to do the down and dirty, what would I have done? I would have just used 42.8 miles and I just would have said it was all longitude. Now I want to show you something. Because I didn't go due west, my D low here was about 40 minutes of arc. Okay, my actual change in longitude was 40 minutes of arc. If I had applied, okay, if I had applied my 43 minutes as that, I would have just been 3 minutes off. Okay, I would have been 3 minutes off, 3 minutes of arc off. Now I just want to show you something. Okay, I just want to show you something. Here's 3 minutes of arc. What's the time difference? 12 seconds. Okay, 3 minutes of arc is 12 seconds of time. It's not going to impact the problem. So what I'm trying to say is this down and dirty works for these problems as well. Okay, so if you understood the down and dirty last class and you want to use it again, you don't have to plot. You can just take the 42.8 miles, pretend it's longitude, okay? And what you would do is you would say, oh, I was at 2320 by 155.15, okay, west. And now I'm going to apply 43 miles. That's going to give me 155.58. And then I would do arc to time for that, okay? And it's only 3 minutes of arc difference, which is only 12 seconds of time. So it doesn't matter. If you didn't understand what I just said, if you didn't understand this at all, then you need to plot on the plotting sheet. And you can just disregard what I just said. Okay? And there's a couple of moonrise and moonset on the worksheet, and let's just ignore them. We're not going to do them. They're on the worksheet, ignore them, and I'm not going to test you on it. The Coast Guard has taken that off the exam. Okay? So I think that concludes the lecture for tonight. So now I can take any kind of questions you got, and I would say you should now work on the worksheet. Okay?